Now let's solve this system of equations, and let's solve it by a couple different methods. Let's first use the substitution method. Okay, so substitution. Substitution method works really well when you've got something like we have here, when you've got one of the equations already solved for one of the variables. Because all I'm going to do is take that and plug it in right there. So I'm going to rewrite that top equation. I'll color code it for you. I'm going to rewrite it as 6x plus 2, but now I'm going to leave the y. I'm not going to write y yet because I'm substituting this in for y, 3x minus 13, because that's what y is. So now we have one equation with one variable. You might say, no, we have two variables, but no, they're the same variable, so I can add like terms. So let's solve this. 6x plus, distribute that in, 6x minus 26 equals negative 2. That means 12x, I added like terms, minus 26 equals negative 2. That means 12x equals, I'm adding 28 to both sides, 26 to both sides, 24. That means x equals 2. I divided both sides by 12. If x equals 2, I can now plug that back in to here. 3 times 2 minus 13 is 6 minus 13, which is negative 7. So my answer is 2 comma negative 7. I check it by plugging in 2 and negative 7 into the other equation and make sure that it works. 6 times 2 is 12. 2 times negative 7 is negative 14. 12 minus 14 is negative 2. It worked. Done. That's the first way. That's the easiest way when it's in this form, but it's not always the best way, and so let's look at another way to do that problem. Method 2, elimination. Elimination method works best when you've got the equations both written in standard form. So we're going to rewrite this in standard form. I'm moving the 3x over, so it's negative 3x plus y equals negative 13, and I'm just going to erase this so that it's not confusing to us. So there's my system of equations. Notice they're both in standard form, and what I'm going to do is I'm going to multiply one of these equations by something so that when I add the equations straight down, one of the variables is eliminated. Can you see what I need to multiply by? This bottom one I can multiply by 2, and when I do that, I'm going to get negative 6x plus 2y equals negative 26. So now that equation's gone, and I'm adding straight down. That's 0x's, so I don't even have to write it, which is, by the way, why they call it elimination, because I eliminated a variable. 2x plus 2x is, 2y plus 2y is 4y, negative 2 minus 26 is negative 28. Divide both sides by 4, I get negative 7. Plug that back in to either one of these for y. Solve for the other one, you're going to get x equals 2, just like we did on the other page. So 2 comma negative 7 is our solution, and we can check it and it'll be true. Alright, that's the second way. Pretty easy method, but there's an even better method. But your teachers don't want you to know this yet, but I'm going to teach it to you now. This method is called using matrix algebra. So I'll explain it to you somewhat quickly as I do this. First of all, notice that I put them both in standard form, because now what I'm going to do is I'm going to convert this equation into a matrix. I'm going to pull out the coefficients. That's called the coefficient matrix. I'm going to pull out the variables. That's called the variable matrix. And I'm going to pull out the answers. That's called the, I don't know what it's called. Let's call it the answer matrix. I don't know if it has a name. So there's my matrices. What are matrices all about, you wonder? Well, you're going to learn about operating with matrices and all that kind of stuff. I'm not going to teach that to you now, but basically, long story short, if you multiply this 2 by 2 matrix with this 2, that's row by column matrix, you're going to end up with the 2 by 1 matrix. 2 by 1 matrix. This means that you're allowed to multiply them together, because what you're doing is you're multiplying this row by this column, and you're putting that right there, row by column, and then you're multiplying this row by this column, and that's where I get that equation. So I'm basically creating another type of algebra with matrices. So you might wonder, well, why would I do that? Well, I'll show you why. Because if I had something like 2x equals 3, how do I solve for x? I just get rid of the 2, right? By dividing it or by multiplying it by 1/2. That's really what I should do. I should multiply it by 1/2. So x equals 3 over 2. Well, look what I have here. I have an equation just like that. I have something. Let's call this matrix right here, let's call that A. And I have another matrix, let's call that X. And I have a third matrix, let's call that B. How can I get X by itself? I could divide by A. Now, there's no such thing as dividing by a matrix. There's not such a thing as that. But what's dividing the same as doing? Multiplying by the inverse. And what's the inverse of A? It's A inverse. So here's all you have to do. You ready for the shortcut? To find the solution to this matrix equation, to this system of equations, go to your matrix button in your calculator, create a matrix and call a matrix called matrix A, and make it a 2x2 matrix and plug in all those values right there. Then create a B matrix that's a 2x1 matrix and plug in all those values right there. All those values right there, -2 and -13. And then clear out to your regular screen and just type in A inverse times B, enter, and it'll tell you the solution. That's all you have to do.